Welcome to The Explainer. Today, we're diving into a problem that makes developers want to pull their hair out, getting AI models to give you reliable, clean JSON. This is supposed to be the easy part, the foundation for building cool automated stuff. But man, it's often the first thing to break.
All right, so here's the game plan. First, we're going to look at why AIs are so messy with their JSON. Then, we'll cover the old, kind of sketchy workarounds people used to use. After that, we get to the good stuff. Modern solutions like structured outputs and function calling that actually guarantee you get what you ask for. And we'll wrap up by seeing how all the big players are tackling this.
Okay, let's set the scene. This whole story really starts with a cry for help that I think every single developer out there can relate to. It's a classic. And here is this post from the Make community forum, just nails the feeling, doesn't it? You ask the model for one simple structured thing, and what comes back is, well, it's close, but not quite. And that tiny little error can just completely derail an entire automated workflow. It's so frustrating. And this right here is the perfect visual. On the left, that's the dream. Clean, perfect, machine-readable JSON. On the right, that's the reality. It's the same information, but the AI decided to be helpful and wrap it in markdown code fences. To your code, which is expecting pure JSON, those little backticks are a total deal breaker. Failure. So before we had these new fancy native solutions, how did people even deal with this? Well, they got really creative with what I like to call duct tape and prayers. Let's look at some of these super fragile workarounds. Oh man, developers tried everything. People were writing these ridiculously complex formulas just to find and strip out those extra characters. They were writing these massive page-long prompts, basically begging the AI, please, please just give me the JSON and nothing else. Some folks even did something truly wild. They made a second AI call just to clean up the garbage from the first one. Talk about slow and expensive. And here's the real kicker with all these fixes. They are built on sand. They are so brittle. It might work today, it might work tomorrow, but the second the AI provider pushes a tiny update, or the model just decides to format its answer a little differently, boom, your whole system breaks. And the worst part, it often fails silently, and you don't find out until your customers are complaining. But thankfully, the story doesn't end there. There is a much, much better way. Now we're going to talk about the modern solution, where we stop hoping for the best and start guaranteeing a result. This is all about structured outputs. So the magic trick here is something called a JSON schema. The best way to think about it is like a blueprint or a contract you hand to the AI. It spells out the exact structure you need, the names of the keys, whether a value should be a string or a number, everything. It's like giving the AI a cookie cutter, so it produces the perfect shape every single time. And you might think creating this blueprint sounds complicated, but it's actually incredibly simple. If you're using Python, for example, a library like Pydantic lets you just define your structure as a simple, readable class. The library does all the heavy lifting of turning that into the official JSON schema the AI needs. And then the final step is just beautiful in its simplicity. When you call the model's API, you just add a couple of parameters. You tell it, hey, I expect the response to be JSON, and then you just hand it that blueprint you just made. That's it. Seriously. No more begging in the prompt, no more messy cleanup afterwards. It just works. So how well does this actually work in the wild? Well, this recent test on a super complex schema shows some really interesting trade-offs. You see, GPT-5 was nearly perfect at following the complex rules. But look at the cost. It was way slower and needed 24 retries to get it right. Gemini, on the other hand, was 4 times faster and only needed 4 retries to get a valid structure, but it did struggle more with those super specific complex details. So it really shows you have to choose. Do you need absolute perfection on a complex schema, or do you need speed and reliability? Getting structured data is a game changer, for sure. But what if you want the AI to not just talk about things, but to actually do things, to interact with other systems? Well, that's where the next level of this stuff, function calling, comes in. This slide breaks down the difference perfectly. Structured output is all about the final answer you show to the user. It's about formatting. Function calling, though, is about what happens during the conversation. It's about giving the model a toolbox of functions like, say, get current weather or book a meeting that it can ask your app to run before it gives you that final answer. It's actually this really cool back and forth dance. First, you tell the model, hey, here are the tools you can use.
Then a user asks something like, "What's the exchange rate for euros?" The model, instead of guessing, sends back a little JSON packet that says, "Hey developer, can you please run the get exchange rate tool for me?" Your code does it, gets the live data, sends it back to the model, and then the model uses that fresh info to give the user a perfect answer.
Now, here's the really important part for anyone thinking about safety and security. The AI never, ever runs any code itself. It only recommends a function to run. Your application is always the one in the driver's seat. You have full control over what gets executed, which is absolutely critical. Okay, let's zoom out a little and look at the whole market. Because while these ideas are becoming standard, not everyone implements them in the exact same way. This chart from technologist Ross Glukov is just a fantastic cheat sheet. As you can see, OpenAI and Google Gemini treat this as a top-tier, first-class feature with strong guarantees. Anthropic has this really clever approach where they get the same result by basically tricking the model into using a tool. And then you have Mistral, which guarantees the output will be valid at JSON, but it leaves the job of checking it against your specific schema up to you. So different philosophies, for sure. So what's the big takeaway from all of this? Look, the shift from just hoping you get clean text to demanding guaranteed structured data is probably the single biggest unlock for building the next generation of AI apps. It's the rock-solid foundation you need to build reliable AI agents and complex workflows that you can actually trust to run your business. And that really leaves us with this final big question. As we get better and better at giving AI these perfectly structured ways to communicate, and we give them a whole toolbox of real-world actions, are we right on the edge of building truly autonomous agents that can manage complex tasks all by themselves? The groundwork, it seems, is being laid right now.